Morning, Hillary. So this is south, right? Yeah, it's north south. And then I think it's down. What? Oh, is that on the side? Because this side should be on like one of the side parts. Like, you know the bathroom is? I think that's like like the library. Something like that.
I did pretty well on those when you did them. We have to get a 33 out of 6. We have multiple choice and then 3 out of 7 and all that. Yeah, I got like a 35 or something like that. Again, it was like a 35. We get our multiple choice. We get our multiple choice.
You need to upload your homework.
Oh, I thought I did.
You uploaded the worksheet, like the blank worksheet.
Oh, I did?
Yeah. So why don't you go ahead and do that now?
Okay.
We're gonna go.
Okay. Alex started it and then I got configured it, so I put it in.
All you gotta do is try it.
I tried. I just got lost.
If you haven't uploaded your homework, upload your homework.
Bro, they said our season is over yesterday. No, for everyone else, it was just seniors if they weren't running play at first, and then apparently it's just like 30 people on Parker that's still.
Quantum worksheet that we did over the weekend?
Yeah. So I was grading them this morning. There was just a blank. There wasn't any work. It was just a blank sheet. Worksheet number 1. No.
No, I went to.
Your last name's Webster, right?
Mm-hmm.
I believe you. I'm just curious now why it didn't show that for me.
Yeah. A little weird.
Maybe I'm thinking of a different Gwen because I've got yours here and it's graded.
Okay.
Must be a different Gwen. Because I do have 2 Gwens.
Oh, really?
Yeah.
When did you upload it?
Last night, I think.
Oh, okay. Oh, okay. Actually, I'm thinking of somebody else. Different person. Sorry. All right. All right, it's time to start.
These butterflies have gone through natural selection alone.
All right, let's get started today. For some reason, my screen is not sharing. Maybe I didn't hit start. How you doing, Eddie? How you doing, EJ? Lilia? Wyatt, how are you all doing this morning? Did you have a good weekend? Everybody doing anything fun? No? Justin Fields got drafted? If I knew who that was, maybe I'd be more excited. Is that the NFL? Ah, gotcha. Let's see, what did I do? I think I did much. Oh, had the first soccer game. So tomorrow you've got your test, okay? So I am gonna be gone from 7:30 in the morning until 2 in the afternoon doing science interviews. So you're gonna have a sub tomorrow. So I'm gonna record myself going through all the answers to the practice test. And then for the first half hour tomorrow morning, bring your earbuds. So for the first half hour, it'll be your time to review. So you can watch the video if you want, Zoran, right? You don't have to watch the whole thing. If you know how to do a problem, you can just skip around to the problems you don't know. There's also another worksheet that I'm not assigning called Quantum Worksheet number 2. That's good extra practice as well. In all honesty, Quantum Worksheet number 1 is very much like the practice test. So you're really basically taking 2 practice tests before you take the real test. So you'll have a half hour tomorrow to just review on your own or watch my video. And then the last hour you'll have to take the test, okay? You must complete the test within that time period, okay? The sub will hand out a paper copy and collect it, but you, let's see, just out of curiosity, well, you guys at home, you're gonna have to obviously take it online, but how many of you would prefer a paper copy versus electronic? Okay, well, I will tell this, if you do the paper copy, you don't have to upload it, okay? If you do it online, then you're gonna have to upload it, okay? So I will explain how to do the problems in the video. All of it. And we're not covering any new material today. So after we go through the worksheet, the rest of the time is for you to do that practice test. So you should have plenty of time, Reese, to get your homework done. All right. So let me share my screen. All right, so just a reminder that you get to use Appendix I. So Reese, you can put your cell phone away. You don't need it. All the equations are in Appendix I. You don't have to memorize them. You can use all your appendices as long as you don't write stuff on them. So like, no, don't be putting example problems on your appendices. Okay. Let's see, what are some of the other equations on there? There's delta x, delta p. What just happened? There's this one. I think that's all. What's going on? Why is it doing that? Okay, try one more time to write that in there. All right, so again, I've said you need to memorize the 8 types of electromagnetic radiation. That's a fancy way for saying memorize the 8 forms of light. So gamma, X-ray, UV, visible, infrared, micro, radar, and radio. Okay. I want to make sure that you understand that all of those travel at the speed of light. So like I said, you know, it doesn't matter, Hillary, if I talk about calculating the speed of microwaves and I tell you the frequency and the wavelength and the energy, it doesn't matter. All it means, Simon, is it's the speed of light. So how fast do X-rays travel? How fast do X-rays travel? Speed of light. So if you're going to get an X-ray today, those X-rays are traveling the speed of light. If you have a red light in your room, that's visible light. How fast does visible light travel? Speed of light. So it doesn't matter if it's a red light, a blue light, a green light, a purple light. Your cell phone. How fast do the radio waves come out of your cell phone? Speed of light. Okay, so don't get confused by any other gobbledygook. If I'm asking you the speed of one of those 8 forms, it's the speed of light. All right, number 2. So we've got an electron jumping from the 2nd to the 5th. Calculate the wavelength. So this type of problem, there are 2 steps. Step 1, we got to calculate the energy change. So I'm going from the 2nd to the 5th. So it's going to be negative 52.2 minus a negative 327.5. So when you're minusing a negative, same thing as adding. So my energy change is 275.3. It's positive because I'm jumping to a higher level. Okay, Nathan, I'm going from the 2nd to the 5th. If you're going to a higher level, Mike, you got to put energy in. All right. So I know my energy, I'm trying to find my wavelength. So then what I do, Atticus, is I go to where all the equations are. Oh, your question, Wyatt, do we have to memorize all the formulas? No. You're not allowed to use note sheets, no note sheets, appendices only. So you're not allowed to use any of your own special notes, just the appendices, that's it. Because in the real world, when you're encountering a problem, there are no notes on how to do that problem. There are books and books and books of equations, but you need to be able to attack a new problem and solve it in science. Does that make sense? Why the difference between notes and appendices? Okay. So when I go look at the equations up here, I'm looking for one that's got energy and wavelength in it. There's only one equation with energy and wavelength. So I know I'm going to have to use that equation. This is step 2, basically, is to use this equation. Now the algebra. Multiply both sides by lambda. Divide both sides by E. Now I've got my equation in terms of lambda. My H value. If the units on my energy are kilojoules per mole, then my Planck's constant must be kilojoules per mole. Now I'm ready to plug things in. Times the speed of light divided by my energy. So let's see here. The kilojoules cancels with kilojoules. Seconds cancel with seconds. Moles cancels with moles. Got the right mole there. So the only unit left is the meters. .35 times 10 to the negative 7. So again, I'm not trying to trick you. These are all examples of problems that will be on your test tomorrow. Okay, there should be no surprises. Okay. So what type of light is this? So like I said, you get to use your appendices. And this is visible light is 10 to the negative 7. That's visible light. So on this side would be 7 times 10 to the negative 7. On this side is 4 times 10 to the negative 7. So 4.35 would put us about there. So the type of light would be blue or purplish, okay? A single photon. So if it's one photon, we're going to use the Planck's constant, EJ, for a single particle. That's that one. They tell us the energy now you find the frequency. So what we do, Hillary, is we go again to our equations at the top. And there's only one that's got E, H, and F. I suggest you follow along, Simon, with your homework. Because make corrections on your homework as we go through this so that you have something to study that's correct. So now we plug in our numbers. Multiply by my energy. Negative 23rd joules per photon. So joules. Oh, wait a minute. What are we? Oh, nope. See, I wasn't paying attention. We're finding frequency, right? I plugged the numbers in the wrong spot. We have to, Jaden, do some algebra here, right? To get frequency by itself, I have to divide by h. You know how I knew I made a mistake? Because my units didn't cancel. All of a sudden I realized I was multiplying joules times joules. I'm like, well, that doesn't get me the right unit. That gets me joules squared. So I knew I did something wrong. If I don't put units on things, well, people always ask me, do I have to put units on all my numbers? Yes. Am I going to take points off? No. On the final answer, yeah, I'll take points off, but throughout the work, no. I mean, if you don't put units over here, I'm not going to take a point off. However, you should be doing that if you want to be a good scientist. Yep. Okay, I'll move it in a sec. Thanks. So this is joules per photon. Planck's constant. Now my units will cancel correctly. Now the joules will cancel with joules. The photons will cancel with photons. My seconds are in the denominator. So if the seconds are in the denominator, it's 1 over seconds. And that's what frequency should be. If I put it into my calculator, I get this. Now, what if I asked you to do this in megahertz? Because that's what radio stations broadcast in, right? Megahertz, Z104, 104.1 megahertz. So a mega of anything is 1 times 10 to the 6th. Doesn't matter if it's hertz or whatever. So I know the problem doesn't ask you to do this, but you should. So an inverse second is a hertz. So then 1 times 10 to the 6th hertz will be 1 megahertz. Okay? Any questions on 1, 2, or 3? So number 4, the only place where people typically went wrong was the fact that your mass has to be in kilograms. So it's things like that you can't look up. You know, if you if you go look up equations, they don't tell you, oh, by the way, don't forget to convert to kilograms. They don't tell you, oh, by the way, it needs to be in meters. And so many times you'll be doing the problem right, but getting the wrong answer just because of a conversion problem. So make sure you show all your work because that's the way you're going to get maximum credit. So 142 pounds, 2.2 pounds. Is 64.5 kilograms. Use Einstein's equation. Plug in your mass. Square it. And you get 5.81 times 10 to the 18th. So what are the units on energy? Joules, okay? So it's probably easier for you to just memorize the units on energy, EJ are joules. As you become more advanced, you will want to remember that 1 joule is a kilogram meter squared over second squared. Okay. So especially when you get to like physics, you want to know how those things convert over. So I've got a kilogram here, meters per second, it's squared. So if you get that, that's a joule. All right. But for you guys, it's probably just easier to memorize. Energy, Jaden, is in joules. Okay. Wattage. Your microwave is 1,280 watts, which means it uses 1,280 joules every second. I'm trying to think, what's the wattage of your iPhone? Does anybody know? What, Zoran? Well, yeah, the maximum wattage. I think it's like 8 watts. I think your cell phone is 8 watts, which means it uses 8 joules per second, maximum wattage. Okay. Obviously, if you've got your screen super bright, it's going to be using more energy. In this case, we're talking about a light bulb, and we've got a 100-watt light bulb. So that means 100 joules every second. So I take my answer from part A. If I have joules on the top, joules on the bottom, and I'm using 100 joules every second, and there are this many seconds in a year. That's on Appendix L, by the way, that. Otherwise, you can just convert seconds to minutes, minutes to hours, hours to days, and do that. But it's actually a lot simpler if you just remember, or I should say, look up on Appendix L, the number of seconds in a year. That comes out to be 1.84 times 10 to the 9th years. So this problem isn't so bad if we deal with silly things like textbooks and baseballs and, you know, like throwing people into nuclear reactors. On quantum worksheet number 2, you don't have to do that one. But on quantum worksheet number 2, I give you a realistic problem where you look at how much mass is destroyed when you combine 2 hydrogen atoms. And I walk you through it step by step by step by step by step. So on the test, it's going to be like this. Okay. A more straightforward, easy problem. But I did want to give you, or at least expose you to, like, one realistic Einstein problem. You'll find that on quantum worksheet number 2 if you choose to do it. Again, that one's optional, but there is a realistic E equals MC squared problem on there. All right, number 5. P is momentum. Okay, you can't calculate it if you don't know what it is. P is momentum. We have the mass. So where are we going to find the mass of the electron? All the masses are on Appendix I. It's a little bit blurry, but here is the proton mass, the electron mass, the neutron mass. So if it's a proton, electron, or a neutron, that's where you go to find it. And they give it to you in grams. And this is again where people mess up, Nathan, is they just write down the mass and they go 9.1. Oops. They just do that. But what does your mass always have to be in, Jordan? Kilograms. So how many grams are in a kilogram, Haley? 1,000. So this becomes the velocity. So now, even if you didn't remember this problem, again, I'm trying to teach you how do you attack a problem. You write down your information. So I've got P, I got mass, I got V. So my equation should have P, M, and V in it. So when I look at all my equations, there is only one that's got P, M, and V. And it's that one. So even like, not just my class, but any class, if you encounter something you don't know, write down all the info, then go looking for the equation, okay? And then when you don't get the right answer, Allison, it's because your mass wasn't in kilograms. Same thing in physics. People will be off by 1,000, like, huh, I got the right number, but I'm off by 1,000. You didn't put it into kilograms. So in physics, things have to be in kilograms as well. So P equals MV, 9.1 times 10 to the negative 31st. Times my speed. I get 1.4. And then the units. Kilograms times meters divided by seconds. Kilograms times meters divided by seconds. So it's like, what does that actually mean? Kilogram meter per second. It's kind of a nonsensical unit, but that's the unit. So that's for 1 electron, okay? For B, there are a couple of ways you could do B, okay? So let me just show you. We just got done using this equation, right? There's another equation that's got M and V in it, and it's this one. Well, if P equals MV, and this is MV, well, that equation would also be true then. And you see that equation on Appendix I. So you could do letter B by using this equation, or you could do it by using that equation. You'll get the same answer. So I'm just going to use this one. Planck's constant. .626. Why? Because I'm doing it for 1 electron. P comes from right up here. And then when I put that into the calculator, my wavelength comes out to be 4.9 times 10 to the negative 11. Now it's probably easier, Lilia, just to write the unit down. So what does wavelength have to be at? What's the unit on wavelength? Meters, okay? You guys are a pretty sharp class. So I'm going to show you how the units cancel, okay? I'm not expecting you to do this on the test, but as you go forward in science, you need to make sure the units cancel correctly. That's the only way you know you did it right. If the units cancel correctly, you did it right. If the units don't cancel correctly, you did it wrong. So a joule, remember, is a kilogram meter squared over second squared times seconds. divided by kilograms meters per second. So there are all my units. It's just an algebraic problem. So what happens when you divide by a fraction? It's the same thing as multiplying by the inverse. So kilograms cancels with kilograms, second squared cancels with second squared, one of the meters cancels with one of the meters, and I'm left with meters. Okay. So again, I'm not expecting you to do this, Josh, on the test, but as you go on in science, the only way, Charlie, you know that you're getting the right answer is the units cancel right. Any questions on 4 or 5? Yep, one. On the final answer, if you put the wrong unit, yeah, I'm gonna take points off, a half a point. So the question was, what if I put down the wrong unit? So let's say you wrote joules. I'd take off a half a point because wavelength is not in joules, right? Wavelength should be in meters. Okay, the answer to this one was 2.89. So number 6 is a little tricky. So our velocity is within those two values. 2.5 times 10 to the 8th minus 2.3 times 10 to the 8th. That gives me my uncertainty in velocity. Okay. That's probably the first tricky part. So if my speed is between 40 and 60 miles an hour, my uncertainty is 20. If I say I'm driving between 40 and 60, my uncertainty is 20. It's basically saying, what's the range? What's the range of where I can find my electron? What's the range of the speed of my electron? I know that's not the correct way to do scientific notation, but it's just easier if we leave it like that. We'll let your math teacher get angry. The mass of the electron, again, it's in grams on appendix I. So Drew, we have to convert it to kilograms. We're trying to find the uncertainty in position. There are two equations. There's this one, or there's this one. Now, I don't see them talking about momentum in the problem here, Simon. So I don't see them mention the word momentum at all. I know my delta V, I know my mass. It must be that equation, okay? So it's not that one. My Planck's constant, this is for one electron. Do the algebra. You want to show your algebra. Remember, if you don't show your algebra, you lose a point. So now I've got my delta X by itself, then I can plug in my numbers. So I got everything in there, and everything will cancel except meters, distances in meters, and it'll come out to be 2.89 times 10 to the negative 12. So that's probably the trickiest one, I think, on that practice test too. And this is the length of your test, your real test too. Honestly, this worksheet is like a test, a practice test. So what questions do you have on number 6? Yep, Gwen. So tomorrow, the first half hour is for you to just watch the video if you desire. I'm gonna tell the sub you've got a half hour to study on your own or together as a group. There'll be a video of me going through each of the problems. You can utilize that tomorrow if you want. Actually, I'm going to upload it tonight. So in that way, you're not forced to watch the entire video. Like if you only have a question on one problem, you can just skip to that one problem. You don't have to watch the whole half hour. So you have about 60 minutes. That should be plenty. If you know what you're doing, it'll be plenty. All right. One last problem. A photon has a frequency of 1.83 times 10 to the 6th. Hertz. What is the energy of this photon? So there's only one equation. It's got energy and frequency in it, and it's that one. This is for a single photon. I'm going to use that Planck's constant. And I get an answer of 1.21 times 10 to the negative 27th joules for every photon. So I put letter B on here just to kind of, again, emphasize the importance of unit conversion. So if one candy bar is $1.21, how much is it for 10 candy bars? What would you do? Times by 10. What if I wanted to buy a dozen candy bars? Multiply it by 12. So it's no different than saying the energy for one photon is 1.21. What's the energy for 10 photons? Multiply it by 10, right? What's the energy for a dozen photons? Multiply by 12. The only thing is we've got just a really small exponent over here. Okay, but the reasoning is the same. Now it says per mole. Well, we know how many are in a dozen, right? 12. How many are in a mole? So if you want to convert it per mole, right? Sometimes they sell bananas per dozen. They sell donuts per dozen. Well, energy, if you want to do energy per mole, then you just multiply it by Avogadro's number. And you get 7.30 times 10 to the negative 4th joules per mole. Now, some people got this answer. So some people got that answer and they're like, oh, I did it wrong. Did they do it wrong? No, they didn't. Their units are different, kilojoules per mole. Okay, so again, that's why, Nathan, you got to put your units, because this is the same answer as this. Okay, so sometimes people do a problem, they get to the end like, oh, I did it wrong. No, you didn't. You did it right. Okay. One last thing here I wanted to point out, kind of like, so sometimes the answer is in joules, sometimes the answer is in kilojoules, sometimes it's per one, sometimes it's per mole. Okay. Now, I don't know why this is the case, but in every textbook I have ever encountered, they only list this for Planck's constant. That's the only Planck's constant I've ever seen. So where did the other Planck's constant come from? I just put it in there. So like when you go to college, you say, oh, there's two values for Planck's constant. Your professor might look at you funny and go, no, there isn't. There's only one Planck's constant. All I did was convert it. And I, to the life of me, don't know why they don't do this. Because what do I do here to convert it per mole? Okay. And then how do I convert the joules to kilojoules? This gives me 3.99 times 10 to the negative 13. I have no idea why they don't publish that in textbooks. Because what ends up happening is then you have to do that conversion for every single problem. If you look back at all the problems we did, you would have had to do that conversion for 1, 2, and 3. So it's just easier if you just write Planck's constant in that. So I just wanted to point that out to you, that you're not going to find that in any other textbook except here in this class. But it makes your life a lot easier. Okay. Any questions on any of the homework before we take a look at that practice test? So it's all the same sort of stuff. Oh, I don't have the answers on here. I thought I had the answers on here. Well, I will, like I said, I'm gonna put the, shoot. I know I got the answers to these somewhere. So the rest of the time is to work on this practice test, okay? I will get the answers either uploaded to Canvas or I'll shoot out an email, one of the two to you, not an email, an announcement, so that you have the answers as you work on it tonight, okay? So for the last half hour or 35 minutes, EJ, Wyatt, Lilia, Atticus, Addie, you guys are supposed to be working on this practice test, okay? Same thing with you guys in the classroom.
Only on Canvas or is it in the?
Practice test, I believe, is only in Canvas. Yes, the practice test is only in Canvas. Do you want it? Do you guys want a paper copy of the practice test? No, I don't think so. I don't think the practice test is in the packet. So if you want, I'll print off a paper copy. So if you want a paper copy, I'll print one off. Just raise your hand so I know how many to print. Okay. So I'll print this off. I will mute myself, but I will have the chat room on and I'll check in with you guys in a second, okay?